friends, thank you for joining me. Welcome to TJ's Math Clinic. In today's lesson, we continue with our solutions to sequence and series. With us here is a subtopic, special cases under AP and GP. A situation whereby we have AP and GP combined together. Let's look at how we can solve this. The first, third, and the ninth terms of a linear sequence, that's AP, are first three terms of an exponential sequence, that's GP. If the seventh term is 14, we are asked to find Roman numerals 1, the 20th term of the AP, Roman numerals 2, the sum of the first 12 terms of the GP. Let's look at how we can solve this together. First thing to do, let's write down the solution here. To resolve this, we need the nth term of AP as well as GP. Nth term of AP, term now, is nothing but A plus number of terms minus 1 multiplied by the common difference. This is now AP. Nth term of GP, number of terms is equals to A multiplied by the common ratio power n minus 1. So we need these two formula. First term of AP, it means A is, first term is A. Third term, substitute n equals to 3. That will be A plus 3 minus 1 is 2 times D, that's 2D. This will now be the third term. Ninth term, n is equals to 9. 9 minus 1 is 8. That will be A plus 8D. Then the first three term of GP now will be, first term, of course, is A. Then second term now, when n is 2, that will be AR. When n is 3, that will be AR power 3 minus 1, of course, which is 2. Very important. Okay, from here it means A is equals to A plus 2D is equals to AR, and the A plus AD is equals to AR squared. A is equals to A, that's equation 1. A plus 2D is equals to AR, that's equation 2. A plus 8D is equals to AR squared, that's equation 3. And we are told that the seventh term, if the seventh term, that's of, if the seventh term of AP now, if the seventh term of AP, this off here, sorry, of AP is 14, it means when seventh term is when n is 7, substitute, we have A plus 7 minus 1, that's 6 times D, that's 6D, is equals to 14. That will lead to equation 4. Very important. From equation 4, we can either make A the subject of the formula, or even from from equation 4, we can make A the subject of the formula. Okay, let's make A the subject of the formula. We have A will be 14 minus 6D. That will be equation 5. Again, we can divide equation 3 by 2. Let's work on equation 3 and 2. It means AR plus 8D will divide A plus 2D. That will be equals to AR squared divided by AR. This will divide it, this will divide, we're left with R now, will be equals to 8 plus 8D plus A divided by A plus 2D. You can call this equation 6. Again, from equation 2, we can make R the subject of the formula. Equation 2 now. So, if we make R the subject of the formula from here, we'll have R will be, that's divide both sides by A. It will be A plus 2D will be equals to A. Let's call this equation 7. Clearly here, we can substitute A into equation 6 and 7. Let's substitute A equals to 14 minus 4D before we equate the two. Very important. Let's move here. It means in equation 6, anywhere we see A, we put 14 minus 6D. It means it will be, anywhere we see A here now, we put, let me write it, put A equals to 14 minus 6D into equation 6. Okay, so this will now be r equals to 14 minus 6d plus 8d divided by 14 minus 6d plus 2d. Okay, what are we going to get? Let's work on this. Then we'll do the same. We substitute equation 5 into both 6 and 7. Okay, so let's move here. So let's resolve this. From here, r now will be equals to 14 minus 6d plus 8d, that will be plus 2d, divided by 14 minus 6d plus 2d, that will be minus 4d. This will lead to equation 8. Again, let's substitute equation 5 into 7 now. Okay? Equation 5 into 7. We'll have r now will be equals to a. In place of this a, we put 14 minus 6d plus 2d divided by, in place of this a, we put 14 minus 6d. Very important. Okay? Let me clean here. Then I will leave that equation 7 now. Okay? Let's resolve this. R now will be equals to 14 minus 6d plus 2d, that will be minus 4d divided by 14 minus 6d. This is now equation 9. So we can equate equation 9 and 8. We can equate the two because they are the same. So let's do that here. If we equate equation 9 and 8, what are we going to have? Meaning r is equals to r. It means 14 minus plus 2d divided by 14 minus 4d will be equals to 14 minus 4d divided by 14 minus 6d. I hope we are together. Here we can factor out 2. 2 into 7 plus d divided by 2 is common to 2 into 7 minus 2d. The same thing, 2 is common, that will be 2 into 7 minus 2d divided by 2 is common, 2 into 7 minus 3d. Okay? Clearly here, we can remove these two, can divide this, we'll be left with 7 plus d divided by this. Let's move here. We're left with 7 plus d divided by 7 minus 2d will be equals to 7 minus 2d divided by 7 minus 3d. We can cross multiply now at this point so that we can find d. And if you know d, we can get the common ratio here. Okay, let's cross multiply. That will be 7 plus d, 7 minus 3d, then 7 minus 2d, then 7 minus 2d. Let's expand. 7 times 7 is 49, minus 7 times, that's 21d, plus 7d, then plus 3, minus 3d squared will be equals to 7, that's 49, minus 14d, then minus 14d as well, then plus this time that will be 4d squared. Okay, let's work on this. This is 49 minus 21 plus 7, that will be minus 14. That's minus 14d minus 3d squared will be equals to 49 minus 28, because minus 14d minus 14d, that will be minus 28d plus 4d squared. This is quadratic. Let's rearrange everything. Let's transfer everything to the right. 4d squared plus 3d squared minus 28d plus 14d plus 49 minus 49 will be equals to 0. Alright, let's add this. This is 7d squared minus 28d plus 14, that will be minus 14d. This will be 0, will be equals to 0. Our end is to find d. Very long, but we'll arrive there. Okay, so at this point we can factor 7d squared. 7d rather is common into d minus 2 equals to 0. So at this point, either 7d is equals to 0, and of course d will be 0, or d minus 2 is equals to 0, of course d will be 2. So we know our common difference as 0 or 2. Very important. Let me remove here. The aim is to find d, then common ratio, as well as first term. Okay, so let me substitute d now. From the first equation, let me write it here. The first term, third term, which is a plus 2d, ninth term a plus 8d, then ar squared. We establish the fact that a plus 2d is equals to ar. Okay. Again, we establish another fact that a plus 8d is equals to ar squared. Okay. At this point, we can substitute. Let's substitute. Then again, a plus 6d is equals to 14. So since we know these are the major equations that we had before, so let's use these three equations. So let's use equation 3 now. When d is 2, what do we have? We can find the first term now. That will be a plus, using equation 3 now. 6 into 2, then 14. A now will be 14 minus 6 times 2 is 12. Then a will be 2. So let me put it here. The common difference is 2. The first term is 2. So we can find the common ratio using this equation 7 now. Okay? Let me clean this. The aim is to find the first term, the common difference, and the common ratio before we can solve this problem. So let's substitute. R now will be equals to A is 2 plus 2 into 2 divided by 2. This will be 2 plus 4 divided by 2. This is 6 divided by 2. That will be 3. The common ratio now is 3. So these are the three information that we have to find. That is why it is very long. Very, very long. So we can clean this now. Let's remove all this. So let's use these three information now to solve this. First question says find the 20th term of the AP. The 20th term, using nth term now, nth term of AP is given as this. This is the nth term of AP. Let me write it here. When 20th term means n is 20, let's substitute. I'll have a plus 20 minus 1, that is 19 times d, 19d. The 20th term now, solution to Roman numerals 1 now. We are starting now. This will now be equals to first term is 2 plus there's d here, 19 into common difference is 2. 20th term now will be 2 plus this 38. That will be 40. So this is the solution to Roman numerals 1. Let's move to Roman numerals 2. We are asked to find the sum of the first 12 times of GP. Sum of GP, given that the common ratio, you know the common ratio is 3, which is greater than 1. Sum of GP when R is greater than 1 is given as sum equal A into R power n minus 1 divided by R minus 1, given that the absolute value of R must be greater than 1. Very important. Okay, so let's look at how we can resolve this. I think I can clean, yes, I can clean here, but we're almost there. Okay, we still need this, yes. So let's substitute now. Sum of the first 12 times. It means n is 12. That's the next information we need. We need this information, we need this, we need this, we need this. Let's substitute. Sum of the first 12 means when n is 12 will be A is 2, R is 3 power 12 minus 1 divided by the common ratio now is 3, that will be 3 minus 1. and we are asked to leave our answer in index form. So sum of the first 12 terms now will be equals to 2 into 3 power 12 minus 1. We close the bracket. 3 minus 1, of course, is 2. We can reduce this. Finally, the sum of the first 12 terms now, let me remove this down, will be, sum of the first 12 terms now will be 3 power 12 minus 1. So this will be the solution to Roman numerals 2. 3 power 12 minus 1, Roman numerals 1, the 20th term is nothing but 40. Very long problem, but we have handled it. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. See you in my next video.